All right, in this video, we're looking at applications of parabolas. So the first question we have, Alex has to build a bridge for a local town. He's putting forward 3 different designs for the townspeople to choose from. So the bridge must be 20 meters long, but it can be any height. Okay, so design 1 is just a basic bridge. What is the length of the bridge? So it's here from -10 to 10. So the length of the bridge, assuming it's in meters. It also says it in the question here. What is the height of the bridge? So we can see that height here. So we can just read that straight from the scale if we like. So here we're at 20 and here we're at 40. So we're going up by 20. So halfway is 30. So each individual tick is 5. So the height of your bridge is 25 meters. And determine the quadratic equation that models the bridge. So you can do it in any form. So factorized form, expanded form, or turning point form. But I always think turning point form is the easiest. So I'm going to do that. So our turning point for this question is at 0.25. And all we need to sketch, to get the equation is another point. So we can use this point here, 10. So that's 10, 0. All right, so your general equation in turning point is y equals a times x minus h squared plus k. So we just substitute these points in. So y is 0. A is what we want to solve, so we'll leave a. X is 10. H is 0. And then k is 25. And let's just solve for a. So you can do this on your calculator unless it was a show that question. So 10 minus 0, so 10 squared is 100. And then we have 100a equals -25. So a equals -25 over 100, which is -1/4. Once you've got that, we still don't have the equation. So here's our general form here. So it's y equals your value of a, x minus h squared plus k. And not k, let's put k in. It should be 25. I wouldn't leave it in this form just because it's not, the most simplified form. So x minus 0 is just x, so it's 1/4 x squared plus 25. And you could have different alternatives to that. If you wanted to write it in decimals, you can. So -0.25 x squared plus 25. You can also graph it on your calculator to check whether it's the right equation. Okay, but I'm pretty confident that it's right. So let's move on to the next one. So Alex wants the bridge to have the same design but have a height of 40. Determine the new equation. So we still have the point 10, 0, but this time we've just got a different height. So that means our turning point has changed from 0.25 to 0.40. And then we just do the same thing as we did before. So we use the general form, the turning point form, substitute in for x, y, h and k, and we've got to solve for a. So you can see some similarities here. So a is equal to -40 over 100. And if we simplify that, that's -2/5. So your equation is y equals -2/5. Remember this just simplified to x squared, so I'm just going to write x squared here plus 40. All right, moving to the next question. So this second design, we're looking at 4 arches. So Alex has designed half of the bridge. He needs to extend the bridge so that it's made up of 4 arches. The 2 added arches are from reflecting the other 2 parabolas along the y-axis. So sketch the reflected arches on the axes. So it's a bit hard to do. I might just move that up a bit. There's questions down the bottom. Okay. So you can see the width of each arch is 5. So we're going to go to here and then to here. Oh. And then your turning point. Now we just have to sketch it, so we don't have to be exact. But basically this is all you have to do. But try to be, well, that didn't go as high as that should have been. That's basically all you had to do. What is the length of the bridge? So we're going from -10 to 10. So again, this one's the same length, it's 20 meters. What is the height of the bridge? So this one's a little bit harder because we can't actually read it straight from the graph. So we're going to have to find the equation of just one of the parabolas. So you can use any of these. I always prefer to use the point 0, 0. And this point here, which is 5, 0. And I'm just trying to think if we've got enough information there to get A. Maybe I need to actually use, I might use -5, 0. Just because we can see on the graph that it goes through this point here. Okay, so we've got these 2 points and a third point, which is -1, 4. All right, so this one here, because we don't know the turning point, we can't really use turning point form, so I'm going to use factorized form. Okay, so we need to work out A again, and I'm just going to do these factors here. So our first one is going to be x plus 0, and then the next one's going to be x plus 5. You can tidy that up, so we've got y equals ax, x plus 5. And then we just substitute in the point. So we're substituting this point here, -1, 4. So y is 4 equals negative a. So a times -1 is negative a. We've got -1 plus 5. -1 plus 5 is 4. So divide both sides by 4, and that'll give you a equals -1. So your equation, just substituting it back to here, it's negative, so we don't need to put that bracket in, so x plus 5, or you could write it in expanded form if you wanted to. So what have we done? Oh, we just done the equation. Okay, so the height of the bridge, so remember it's halfway, so we just did the equation of this red part here. So your turning point is halfway between these 2 points, so 0, -5. So you're turning, oh, I'm running out of room here, sorry. Here I was thinking all I had to do was get the equation. I didn't realize we had to find the height. Okay, so our turning point is at x equals -2.5. Okay, so halfway here. So I'll just substitute -2.5 into here to get y. So it's going to be minus -2.5 gives you positive 2.5, and then x plus -2.5 plus 5. So it's going to be y equals 2.5 times 2.5, and that is y equals 6.25. And you can see it's just above 6, okay, but you have to give the exact value. So the height of your bridge is 6.25 meters. Now, just making sure, I can't think of an easier way to do that. So yeah, just finding the equation first, which is a bit tricky in itself, and then understanding that your turning point is halfway between your x-intercepts. Okay, so question 4, determine the quadratic equation with domains that models the bridge. That's a bit of a pain in the bum. So question 4, and we didn't really cover domains, but you will if you go on to do methods next year. So I'm just going to clear everything for now. Okay, so that was our red one, and I just need to draw the other two. Oh God, it's terrible. Okay, so the domain of this one is for x is between -5 and 0. So we can just write that like that. Okay, so it's just true for here because we've basically been doing parabolas and the parabolas keep going. But when you get into methods, you'll have restrictions, and that's what the domain is. So restrictions on your x values. This one here, basically everything's going to be the same. The only difference is your factors. Okay, so we're still going to have the negative. So your dilation factor is the same, but this one here is going to be x plus 5, x plus 10. And that one is between -10 and -5. So this just means x is less than -5 but greater or equal to -10. This one here, okay, is basically the same as this, but we've got x minus 5, and that is between 0 and 5. And then this last one, similar to this second one here, we just have x minus 5 and x minus 10, and that's between 5 and 10. Okay, so there's our 4 equations. In your assessment that you are doing in class in 2017, you don't have to do the domains. Okay, so you don't have to think about the restrictions on that, but it's a good thing to actually think about for year 11 and for year 12. Okay, let's move on to the third one. So here we've got a fancy bridge. What is the length of the bridge? So this one again is 20 meters. What is the height of the bridge? So we can see from here that it is at 9. We can also calculate what that is. So we shouldn't assume that it's at 9, but to do that we do need to use the turning point and another point. And if we did that, it's going to be 9. So let's just read it from the graph to be 9, although we shouldn't ever assume, but we are just for the sake of time here. Determine the quadratic equations with domains that model this bridge. Okay, I'm not going to do every single one of them because it's going to take us a while, but I might just do the pink one just because you do need to know how to get an equation from a graph. So the turning point for this one here, we're going up by 1, so 1, 2, 3. So that's at 3, 0. And we just need another point to get our equation. So we know this point here is 0, 9. Okay, so we can use those 2 points in turning point form to get our equation. So let's just substitute them in. I'm going to quickly do this. So -3 squared is 9. So A is going to be 1. So your equation for the pink one only is going to be y equals x minus 3 squared. Okay, so that's this equation here. You can, if you want to go on and do the rest. If we were doing the domain for that, so we're going from 0, and it looks like it's 5.5. Okay, so you can always check on your calculator. I'm not going to do every single one because I don't want to keep the video too long. The townspeople have decided they like the third design, the fancy bridge. However, they want the maximum height of the bridge to be 5 meters. The turning points of the parabolas must be the same. only the dilation factor will change. Determine the dilation factor that will allow the bridge to have a maximum height of 5 meters. Hence, find the new equations that make up the parabolas of the fancy bridge. Oh, this is a pain in the bum, this one. So basically, what it is saying is they want to change the height. So this time, the height has to finish here at 5. And it's a shame I can't read the question at the same time. The turning points of the parabolas must be the same, only the dilation factor will change. So basically, we got to make this these graphs wider. So what I might do is just do it with the pink one. So see how this pink one reaches here. So basically, it's saying it wants it to stop here. So you're making the graph wider. And when you do that, you're changing the dilation factor. So we still have the same turning point as before, which was 3, 0, but we've got a new maximum height. So that's going to be at 0, 5. And you can just get the equation the same as before. So y equals ax minus h squared plus k. Y is, sorry, let me just think. Yep, 0, a 3 minus 0 squared plus 5. Hold on, no, I've substituted that in the wrong way. Sorry, I done it around. I thought I was doing it the wrong way. Okay, sorry, the y is 5. Okay, and the x is 0 minus 3 plus 0. Okay, so I was substituting the turning point instead of the point. Okay, so 5 equals negative 3 squared is 9, so 9a plus 0. So a is equal to 5 on 9. So your equation for this new one would be y equals 5/9 x minus 3 squared. And you don't have to put the plus 0 on the end. You can go ahead and do the same for the rest of them. Okay, so your dilation factor is probably going to be the same. You're just going to be changing your graphs, basically. And we've already found the dilation factor for the pink one, so the dilation factor for the rest looks like it's going to be the same. So for your assessment tomorrow, this is just an example. If I were you, I would go back to your website and do these questions if you haven't already done them. So let's just quickly get them open. So there's a few questions there to do. And then there's answers. And you actually received a copy of this. I think I fit 2 pages on 1 page to save paper. But if you've misplaced it, then here's a copy. But do email me if you need any help. But I think you've got plenty of revision. You don't want to overwhelm yourself with too much. Okay, bye-bye.